Okay, so just a quick check if you guys can hear me and also see my screen. Yes. All right, good. Let's begin then. So I'm just start the recording as well, so I can share that with you. Okay, so let's start with this one. November 2022, paper 1, variant 1. So first of all, let's look at the questions that you've asked from this paper. Okay, so from this variant, we've got 3 questions primarily that most of you have asked about, 7, 8, and 10. And then from the next one, we don't have many. Then there are more from the third variant. Okay, all right. Okay, so let's get started with this one. So from this, I'm first going to do question number 7 that has more votes. Let's start with that. This is November 22 question number, paper 1, variant 1. We're starting with question number 7 from this first of all. Okay. A tool for putting fence posts into the ground is called a post rammer. The distance is in millimeters that the post sinks into the ground on each impact of the post rammer follow a geometric progression. Okay, so we've got a GP, a geometric progression. The first 3 impacts cause the post to sink into the ground by 50 millimeters, 40 millimeters, and 32 millimeters respectively. Verify that the 9th impact is the first in which the post sinks less than 10 millimeters into the ground. Okay, now how do we do that? We've got a geometric progression. The first term is 50, the next term is 40, the next is 32 after that, and so on. We know that the first term is 50 from this progression. You know that the ratio is going to be 40 over 50 next term divided by the previous term. So that turns out to be 0.8. That's the ratio. So we know the ratio of this GP. We know the first term of this GP. Now we need to verify. They don't want you to find something. They want you to verify. So they've given the answer already. You just need to verify this. What do you need to verify? That the 9th impact is the first in which the post sinks less than 10 millimeters into the ground. Now you can see it's not less than 10 millimeter yet. If 9th has to be the first one that sinks less than 10 millimeter, what that means is the one before that should be greater than 10. So what we can show something like this. We can say, let's find the 8th term of the sequence and see what that turns out to be. How do you find the 8th term? It's a GP. The geometric progression formula, the nth term formula for a GP is given by this. We can say T8, that equals A, which is 50, into R, which is 0.8 raised to power n minus 1, so that's 7. And that will give you some value. You can see what that is. Can anyone tell me what this value is? Do you get for this? $10.4857. Okay, thank you. 10.4857. So we can say 10.49 for this. Now the 8th term is greater than 10. Then we can find the 9th term. See what that turns out to be. 50 into 0.8 raised to power 9 minus 1. That will be 8. See what that turns out to be. What about this now? That's 8.388, 8.39. And that proves it that the 9th impact is the first in which the post sinks less than 10 millimeters into the ground. This number is greater than 10. This is less than 10. So that's what we had to prove. Okay, this is the first, and 9th term is the first one that is less than 10. That's what you had to show there. Now it says, find to the nearest millimeter the total depth of the post in the ground after 20 impacts. Okay, now how do we think about this? Okay, so the first one, makes the post sink into the ground by 50 millimeters, the next one 40, the next one 32, and so on. If there are 20 impacts, what's the total depth going to be? We can just add all of those numbers up, find the sum of those 20 terms. The first term is 50, the ratio is 0.8. Let's find the sum of the 20 terms. What's the formula for nth term for sum of n terms for a GP? It's a into 1 minus r raised to power n divided by 1 minus r. Just input values in this. A is 50 into 1 minus 0.8 raised to power n, which is 20, divided by 1 minus 0.8, and that will give you something. Let's see what that is. 247.1. That's the result that we get from this. You can round this out to 3 significant figures and say this is, in fact, okay, so the question says to the nearest millimeter. Okay, so now we have to be careful about this. These are given in millimeters. Okay, so we have to round this out to the nearest millimeter, and that will give us 247. Rounding this off here is necessary. The question statement itself says that. That means it's definite that you would lose a mark here if you do not follow that instruction. Okay, so you have to make sure that you follow that instruction, and you write the answer as just 247, and that's your final result. Okay, let's move on. Now, part C says, find the greatest total depth in the ground which could theoretically be achieved, right? So if you keep making these impacts forever, what's the total depth that you could theoretically achieve? That's basically sum to infinity. So if you had infinite impacts, what will be the total sum that you get from that? A is equal to 50. R is equal to 0.8. Just find the sum to infinity for that. A over 1 minus R. That will be 50 over 1 minus 0.8. And you can see what that turns out to be. 50 over 0.2, that's 250. And that's the final answer that you got. Okay, so that was fairly straightforward. It's just that they had given this whole scenario in the form in 3 sentences. You had to understand what they're saying. But in terms of what you had to do, actually, it was not that complicated. All right, so that was question number 7. That's one question that you guys were asking about from this paper. Let's move on. The next one is question number 8. Okay, let's try this now. It's a functions question now. The function f is defined by f of x equals 2 minus 3 over 4x minus p for x greater than p over 4. Okay. Find f dash of x, that means the derivative of f, and hence determine whether f is an increasing function, a decreasing function, or neither. Okay, so let's find the derivative first of all. F of x is 2 minus 3 into 4x minus p whole raised to power minus 1. We can write it like this, right? We can bring the denominator to the numerator so that we can differentiate it then. Now, what's the derivative of 2? That's a 0. Derivative of the second term, minus 3 remains as it is. You multiply by the power, you subtract 1 from the power, and you multiply by the derivative of what is inside. That is 4. Let's multiply by that. Now we can simplify this. Minus 3 into minus 1, what's that? That's 3. And we've got this 4 outside as well. So that will become 12 into 4x minus p whole raised to power minus 2. Now we can write this as 12 over 4x minus p whole squared. Now, what can we say about this? Is this derivative greater than 0? Is it less than 0? Or is it greater at some point? It's less at some point. Can you say anything about it? The numerator is a positive number. 12 is a positive number, right? The denominator is a square. A square can also not be negative. So we know that the numerator is a positive number. That's 12. The denominator also has to be greater than or equal to 0. It can't be 0 because in that case, you would have 0 in the denominator. In the question as well, they have specified that x is greater than p over 4. If x is greater than p over 4, you can say that this expression is always going to be positive, right? Because when x is equal to p over 4, you get 0 inside. When it's greater than p over 4, you will always get a positive number. So numerator is positive, denominator is positive. You think about it like this, and then you say, since the derivative is greater than 0, what does that mean? It's an increasing function throughout. For any value of x, this function is always going to be increasing because the derivative is always positive. Derivative is always positive. Does that make sense? Any issues with this? All right. Okay. Let's move on to the next one now. It says express f inverse of x in the form p over a minus b over 6x cx minus d, where a, b, c, and d are integers. Now, how do you do that? You have to find the inverse function. You've got f of x. What's f of x going to be equal to? F of x is equal to 2 minus 3 over 4x minus p. That's f of x. 2 minus 3 over 4x minus p. And the domain that we're given is x greater than p over 4. That's the domain that we're given. How do you find inverse of this? You start like this. You say let f of x be y. And now we make x the subject. So y equals 2 minus 3 over 4x minus p. Let's take this term to the other side. Bring y to the right side. And see what that gives us. 3 over 4x minus p, that equals 2 minus y. Now, since I want to make x the subject, I want this in the numerator. So what I'm going to do now is I'm going to take this to the numerator here and bring 2 minus 1 down here, that whole thing. So it becomes 3 over 2 minus y equals 4x minus p. Let's take p to the other side now. So it becomes 3 over 2 minus y plus p. That equals 4x. And now we can divide by 4 on both sides. Now look at what they want here. They want a form like this in which the terms are separate like this. So we want these two terms separated. We don't want to take LCM, but let's divide by 4 and see what that gives us first. I'm just writing this 4x on the left side now, x on the left side, and then divide by 4. What will that become? When we divide this thing by 4, in the denominator, we end up getting 4 into 2 minus y, so that becomes 8 minus 4y, and then p over 4. And now we could say f inverse of x, therefore, that is equal to 3 over 8 minus 4x plus p over 4. That's the f inverse function. Now we have to think about how to convert it to the form that they want. So they want p over 4. So they want p over a. We've got p over 4 there. So that's done. There's no problem with that. I can write that first, just like they've written there, although it would not make any difference. But let's do it. Let's write it exactly in the form that they want there. P over a, okay, and then they have a negative sign between the fractions. We are getting a positive sign. How do you make the sign? How do you make the sign negative? This is positive. And inside in the denominator as well, you can see that they have cx minus d. The x term is first and the constant is second, right? So what can we do here? What we can say is, let's take minus common. Let's take minus common from the denominator here, so that we have the x term first and we have the constant term second. Okay. What will that become? We have minus 3 over 4x minus 8. That is f inverse of x. You can write it like this. So what I've done is, in the denominator, I've taken minus common outside. So that leaves me with minus 8 plus 4x inside. Okay. And now 4x, that becomes 4x minus 8. And this minus I've written with the fraction. And that's the result that we wanted. This is exactly the form that they wanted there. Is that all right? Any issues with this? Any problems with this, anyone? Okay, good. Let's move on. Now it says, hence state the value for P for which f inverse of x is identical to f of x. How do you think about this now? Where f inverse of x and f of x, they are identical to each other. Now, what was the expression for f of x and what was the expression for f inverse of x? Let's have a look at that. F of x was this. Let's write that down here. F inverse of x is p over 4 minus 3 over 4x minus 8. This is identical to f of x, which was 2 minus 3 over 4x minus p. Now, if both of these are identical, that means every term is supposed to be identical. These two have to be identical, and this fraction should be identical to that fraction. Now we can compare the two. We can either say p over 4 equals 2, and that gives us p over 8, or we can say this 8 here also corresponds to this p. That also gives us p equals 8. So that's the result that we write there. We say p equals 8. That's the solution that we've got. Make sense? So the value for p, therefore, should equal 8 here. When we compare these two as well, we get p over 4 equal to 2. The value of p is 8. Yes, we're doing comparison. That's what we do when we have identities. When we multiply a fraction with minus, what happens? So if you have a minus sign here and you have a minus b over c minus d, this minus could either be multiplied with the numerator or with the denominator, not with both of them. You multiply that with any of them. You could put that negative either here, or you can put that negative here, or you can put that with the whole fraction. All of them are the same. You don't put that with both numerator and denominator at the same time. That would be wrong. You put them in any one of those places. Is that okay? This can never be proved by inputting values. When you're proving something is always positive or always negative, you can never do that by inputting values. Because how many values would you input? You can input 10 values, and for all of them, if it is positive, that does not prove that it's positive for every possible value. Because what if there was some other value at which it turns out to be negative? So inputting values in such problems does not help. That's not going to give you the correct result. Unless it was the neither case. For proving this, that it's neither, inputting values might work in some cases, and that would be that you show that at one value at one value the derivative is turning out to be positive, at another value it's turning out to be negative. So it's neither always positive nor always negative. So it's neither increasing or decreasing. But for proving that it's always increasing or always decreasing, inputting values never works. That's not going to work. Okay. All right, let's move on now. Question number 9. Okay, nobody asked about this. So the next question that we have from this paper is question number 10. That's the next one that you guys are asking about. And then we move on to the next paper after that, after a short break from Maghrib. Please make sure to respond to the poll for the other group, for the other paper as well, P12. Can everyone please respond to that poll as well? Okay, let's try this. Have we got a positive denominator? Okay, let me go back there. Have we got a positive denominator there? In part A. Because it's a square. A square can never result in something negative, right? the output from a square can never be negative. The least it can be is 0. But in this case, it can't even be 0 because 0 would be when x is equal to p over 4. And the question says x is greater than p over 4. So it can't even be 0. It has to be positive because it's a square. Square cannot be negative. Okay. All right. Question number 10. That's the next one that we have from this paper. Curves with these two equations intersect at A and B. We've got their points given. Find the area of the region between the two curves. Area between two curves, area between two graphs. How do you find that? Area under the upper curve minus the area under the lower curve. That's what you have to do, right? Okay. Now we have the upper curve. What's the upper curve? In this part for which we have to find the area, in this part, the upper curve is this yellow one that I've shaded there, that has this equation. And the lower curve for that part for which you have to find the area is this one. This is y equals half x squared minus x plus 1. Now, we just have to integrate both of them, input limits from 0 to 4. The x coordinate of b is 4, and that will give you the area that you're looking for. Now, what's the upper curve? Let's write that down here. The upper curve is y equals 2x raised to power 1 over 2 plus 1. What's the lower curve? The lower curve is y equals half x squared minus x plus 1. These are the two functions that we've got. Okay. Now we can either integrate both of them separately, input the limits in them, and then, find the areas and subtract them. However, in this case, since both of them have the same limits, both of them have limits from 0 to 4, it will be more efficient. It will be more efficient if we just subtract these two functions first and then input limits once. Okay, input limits together on both of them. That will be more efficient. So let's do that. You can do it both ways. If you get confused by this, you can do it separately, and that's okay. For volume, I would recommend you always do it separately. For area, sometimes it becomes more efficient if you have the same limits that you first subtract and then integrate. So in this case, let's find the difference of these two functions. What does that turn out to be? 2x power 1 over 2 plus 1 minus half x squared minus x plus 1. Let's simplify this. 1 and 1 get cancelled, and we're left with 2x raised to power 1 over 2 minus half x squared plus x. This is the expression. Now what we can do is we can integrate this, input the limits from 0 to 4, and that's going to give us the result. What's the integration of this? 2x raised to power 1 over 2. Add 1 to the power, it becomes 3 over 2. Divide by the new power. Minus 1 over 2 remains as it is. Add 1 to the power, that's 3. Divide by the new power. Plus x, that's x squared over 2. So we are done with the integration part. Now, before you input limits, simplify this a bit first. 2 will go to the numerator. 2 into 2, that becomes 4. So you have 4 over 3 into x raised to power 3 over 2 minus 1 over 6 x cubed plus x squared over 2. Now you can input the limits, input 0 ones, input 4 ones, find their difference. Let's input 4. 4 over 3 into 4 raised to power 3 over 2. Subtract from that 1 over 6 into 4 cubed plus 4 squared over 2. Subtract from this the case when you have x equal to 0. Since every term has x multiplying with it, when you input x equal to 0, everything is going to become 0. So we can just write 0 there, or even just ignore that, and that's going to be okay. Evaluate this, and that will give you the result. I don't want an exact answer as such, so you can just put this on your calculator at this point after inputting the limits, and you would get that result. What do we get from this? 8. Okay, so 8 is the final result that we were looking for. That's our final answer. Okay, let's move on. That was part A. Now it says the acute angle between the two tangents at B is denoted by alpha, and the scales on the axes are the same. Find alpha. Okay, so how do you think about this? Acute angle between the two tangents. Angle between two lines. Does that remind you of something? Angle between lines formula. We did this in coordinate geometry. What was the formula? For angle between two lines, we can use this formula: tan theta equals m1 minus m2 divided by 1 plus m1 times m2. Right, that's the formula that we have here. Right, m1 minus m2 divided by 1 plus m1 m2. So what we need is the gradients of these two tangents. Once we have the gradients of the two tangents, then we can just use this formula to find that angle that we're looking for. Okay. Now, how do you find the gradients of the two tangents? Gradient of a tangent is the same as the gradient of the curve at that point. So we can find the gradients of the curves at the point B. For both of those curves, we can find their gradients, and the gradients of the tangents are going to be the same. Then we can then just use that formula. So let's write down the two functions that we've got. One function is y equals 2x raised to the power of 1 over 2 plus 1. That's one function. And the other function is y equals half x squared minus x plus 1. Half x squared minus x plus 1. This is the other function. Let's differentiate both of them so we can find the gradients of these curves at that point. What's the derivative of this going to be? 2 into 1 over 2, that becomes 1 into x raised to the power minus 1 over 2. Derivative of 1 is just 0. This is the derivative that we're getting for the first function. For the second function, we get dy over dx half into 2, that becomes 1. Subtract 1 from the power, that just leaves you with x here. Derivative of minus x is minus 1. Now, in both of them, you can input the x coordinate of that point. The point is 4, 5. Its x coordinate is 4. Let's just input that value, put x equals 4 in this, and that gives you dy over dx equals 4 raised to the power minus 1 over 2, and dy over dx equals 4 minus 1. What do we get from both of them? The first one gives us 1 over 2, right? That's 0.5. And the second one, that gives us 3. So the two gradients that we are getting are 0.5 and 3. Now, these are the gradients of the curves at that point. What are the gradients of the tangents going to be? They're just going to be the same as these gradients, right? Because gradient of a tangent at a particular point is the same as the gradient of the curve at that point. So we can say one of these is m1 and the other is m2. Just input values in the formula and you get a result. What's the formula? Tan theta equals m1 minus m2 divided by 1 plus m1 m2. Now you can call any of them m1, any of them m2, and it would not matter. You can call any of them m1, any of them m2. That would not matter. However, since we want an acute angle, in the first quadrant, tan is positive, right? So we can take m1 to be the value that's the bigger one and m2 the smaller value, and that will directly give us the acute angle. Okay, so if you take m1 as the bigger value and m2 as the smaller value, you would get an acute angle directly. If you take m1 as the smaller value, then you would get an obtuse angle. So you can do it like that if you understand that. If not, you can just input them directly and that's okay. If you get an obtuse angle, you'll just do 180 minus that and you can get the acute angle corresponding to that. So if you want to do it directly, that's also fine. You can say 0.5 minus 3 divided by 1 plus 0.5 times 3. What do we get from this? Minus 2.5 divided by 2.5, that's minus 1. Can somebody confirm this? What's the value that we're getting? Minus 1. So what's the value of theta that you get from your calculator for this? What does the calculator give you for this value? Tan inverse of minus 1? Is that minus 45 or 135? So calculator will give one of those, right? So okay, so calculator is giving you minus 35, minus 45, sorry. Now, we don't care whether the angle is minus or plus. We can just say the angle that we were looking for, that's just 45 degrees, and that's our final answer. Okay? Any issues with this? No? No problems? Okay, all right. So what I'm going to do now is we're going to have a short break now, about 10 minutes or so for Maghrib, and then we come back at around 7:10, inshallah, when we do some questions from the next paper now, which is paper 1-2. Okay, so if we come back in about 10 minutes, I will copy that next paper for you here. So if you get back earlier, you can start thinking about those questions. November 2021, 2022, sorry, paper 1, variant 2. Okay, I don't have many responses on the poll yet for this paper. There are many on 1-3. Not many on this. Okay, so if you haven't gone through the paper yet, please at least have a look at the paper, identify the questions that you find difficult, or was it a very easy paper that you don't have any questions from it? Either way, have a look at the paper again. Let me know if you have any problems, respond to the poll. We will come back in about 10 minutes, inshallah. Okay? We are going to resume around 7:10 p.m. We have a short break for Maghrib, and we come back after that. Okay, let's resume. So this is the next paper that we're doing now. November 22, paper 1, variant 2. Difficult questions from this paper. So there are two questions primarily that you're asking about from this paper. Let's have a look at those two. Okay, so question number 5 from this paper you're saying, and question number 10. All right, let's have a look at these two questions. Questions 5 and 10 from this paper. Okay. The graph with this equation, y equals f of x, is transformed to the graph with the equation y equals g of x by a stretch in the x direction. That's a horizontal stretch. And the factor, the stretch factor, the scale factor, that is 0.5, followed by a translation of 0, 1. Okay, the diagram below shows the graph of f of x. On a diagram sketch the graph of g of x. So f of x graph is given. You have to transform it to g of x. How do you do that? How do you go from f of x to g of x in this case? Let's do this stretch first of all. Scale factor 0.5. Horizontal stretch, that is supposed to change only the x coordinates, right? So x coordinates are going to change. They're going to get multiplied by 0.5. So every x coordinate after the stretch will get multiplied by 0.5. So that's the first thing that we do. Multiply each x coordinate by 0.5. Now this one remains here. That does not change. This is 1. This point here is going to go to 0.5. So that point will come here. This point here has an x coordinate of 2. 2 into 0.5, that becomes 1. So that point will come here. And similarly, the next one, this is at 3, it will come to 1.5. And this is at 4, it will come to 2. So after that horizontal stretch, which is actually a compression because the scale factor is less than 1, after stretch, you already have a figure that looks like this. This is the result that you have after stretch. Okay. And then you have to do a translation 0, 1. What does that mean? 2 units in the upwards direction. That's the translation that you have to do now. So move the graph 2 units up and see what that gives you now. Every point will move 1 unit up. So you get something like this. You start from here and you go here. This is what you get. You will draw this using a pencil and a ruler. So you draw straight lines like this. So every point moves 1 unit up because of this. And you get a graph that looks something like this. This is going to be the final result. This is the graph of g of x. That's what we were looking for. You can label this here. This is g of x. Make sense? Any issues with this? All right. Okay, good. Let's move on to the next one. Now it says find an expression for g of x in terms of f of x. Again, that's fairly straightforward. What are the two transformations that have happened? We had the graph f of x. We have stretched that by a factor of 0.5 in the horizontal direction. Horizontal stretch scale factor, 0.5. In horizontal stretch, we know it's the other way around. For example, if you have f of b times x, the scale factor is reciprocal of this, that's 1 over b. So if the scale factor is 0.5, what is the number here going to be? The number that we multiply there? 1 over 0.5, and that gives us 2. So inside the function here, we would have f of 2 like this. So it will be f of 2x. Because when you multiply by 2 inside, that's a stretch in the horizontal direction by a factor of 1 over 2 or 0.5. That's one thing that's happening. Then the other thing is that you have a translation. It's a vertical translation, 1 unit up. So the graph has to move vertically in the upwards direction. So outside the function, you add 1. You do +1 outside the whole function. So you have +1 outside. This is what g of x is going to be. G of x is f of 2x plus 1, and that's your final result. Okay, let's move on. That was one question that you asked about from this paper. And then question number 10, let's move on to that. And then there are more questions from the third variant that you guys have. Apparently, that was a relatively more difficult paper. So let's just do one more question from this paper. That's question number 10. Okay, this one you're saying. All right. The diagram shows a cross section RASB, a cross section RASB of the body of an aircraft. Okay. The cross section consists of a sector OARB of a circle of radius 2.5 centimeters. So this is the cross section. This whole thing apparently, RASB. Yeah, so this whole thing is the cross section, all of this. Now it consists of two parts. One is a sector with the bigger circle, 2.5 meter radius, and the other is a sector of a circle with a smaller radius. One has center O and the other has center P. These are the two centers. And we've got the angles given as well. It does not look that difficult. Maybe the figure first up is a bit scary, but you've got all the information given, so it should not take that long. It says find the perimeter of the cross section, giving an answer correct to 2 decimal places. Perimeter means the outer boundary. Now, what's the outer boundary? You've got this arc length here, and you've got this arc length here. All we have to do is just add these two lengths. These are arc lengths. Can we find these arc lengths? We've got the angles given as well. Let's find the arc ASB first of all. Arc ASB, the green one. S equals r theta, radius is 2.24 for this arc, this one, and the angle is 5 pi over 6. So 2.24 into 5 pi over 6, and that will give you something. What do you get from this? What do we get from this? $5.864. Okay, thank you. 5.864. That's the result that we get for this arc, the green one. And then the yellow one, what would that be? Now, do we have the angle for that? We have this angle. This is 2 pi over 3. So what's the outer angle going to be? The other side, what's this angle going to be? It's going to be 2 pi minus 2 pi over 3. 2 pi minus 2 pi over 3. What does that turn out to be? 4 pi over 3. So that's the angle for that bigger arc now, the yellow arc. That's 4 pi over 3. Radius is 2.5. Let's find that arc length. Arc ARB now. That's the bigger arc. Radius is 2.5. And the angle is 4 pi over 3. And that should give you the result from this 10.472 or 10 pi over 3. Okay, thank you. That's the other point that we get. And now that's the other length that we get. We can find the complete perimeter now. Just add these two up and you get the final answer. That's 5.864 plus 10 pi over 3. And that will give you the result. You can see what that is. You have to give an answer in decimals. Generally, we prefer using exact values, but since the question specifies that you want an answer in decimals, you have to make sure that you write 2 decimal places here. 16.34. Okay, 16.34. This is the final answer that we've got. That's what we were looking for. Okay, that was part A, fairly straightforward. Now it says find the difference in area of the two triangles AOB and APB, giving an answer correct to 2 decimal places. AOB and APB, we want to find the difference between these two triangles. AOB and APB. Okay. How do you do that? We can use half AB sine C, right? We have these lengths for both the triangles. This is 2.5 and this is 2.24. For both of them, we can use half AB sine C, right? So let's do that. Area of triangle AOB minus the area of triangle APB. Half into AB sine C. That's the formula that I'm using here for the area of the triangle. Half AB sine C. With these are two sides of the triangle, and the angle C is the angle between them. 1/2 into, for the bigger triangle, the sides are 2.5 and 2.5, and the angle is 2 pi/3. Let's do that. 1/2 into 2.5 into 2.5 into sine of the angle, that is 2 pi/3, minus 1/2 into the smaller triangle's sides. They are 2.24 into sine of the angle between them. The angle between them is 5 pi/6. Now, since you want an answer in decimal form, you don't have to show working. You can write down the answer directly after this. As no further working than this, you have to show this step, yes. But then after this, you can write down the answer directly from your calculator, and that will be fine. So that's giving you 2.70. No, 1.45 is the final result. Okay, all right. So after doing the complete calculation, you're saying that's 1.45. To 2 decimal places again, that's your final answer. Okay, that's the difference between those two areas. Now it says, find the area of the cross section giving an answer clear to 1 decimal place. So now we want to find the area of that complete figure that we saw there. We want that complete area. How do we do that? How do you find that complete angle, complete area? What we have done now is we have figured out the area of this region in the previous part. Area of this region, right? When we found the difference of the areas of the two triangles. That's what they made us find in the previous part, this area, right? So that makes it easy for us now in the next part, because once we've got this yellow area, the rest is just this bigger sector here and this smaller sector here. So we just find the areas of these two sectors, add them up to the answer of the previous part, and that will give you the final result, right? So that's what we can do here. If they had not asked us to find that difference in the previous part, it would have been much more difficult. You would have had to do all of this thinking yourself, that how you would first find this yellow region by subtracting the areas of the two triangles, and then add the areas of the sectors to that, right? But in this case, they've made it easier, that they've made you find the area of that triangle first, and then you can just find the areas of the sectors, add them to it, and you get your result. So let's find the areas of those sectors. Area of the smaller sector, the one below, that's ASB. Let's see what, no, that's PASB. Half r squared theta, radius is 2.24 into theta, that is 5 pi/6, and there's a square on top of this. And that will give you the area of the smaller sector, half r squared theta. You can see what that is. Evaluate this and see what you get from that. Then you find the area of the other sector. That will be OA, RB, right? That's the bigger sector, this sector, OARB. Find the area of this sector now. Again, half r squared theta, radius is 2.5. So 1/2 into 2.5 squared into the angle. The angle is 4 pi/3, and that will give you another value. So what do we get from this? The first one is 6.568. Okay. And the next one, 13.0899. And then you find the total. The total area of that cross section, what does that turn out to be? 6.568 plus 13.0899. These are the two sectors that we had here, this sector and the sector below, plus that yellow region that we found in the previous part, that was 1.45. We also add that to it. And that will give us the final result. You can see what that turns out to be. That's 21.1. We want an answer to one decimal place, so that's our final answer, 21.1. That's what we were looking for. Okay. Any problems with this? Makes sense to everyone? Okay, so that's it from this paper then. Let's move on to the next one. November 2022, paper 1, variant 3. And apparently this is relatively more difficult. We have more questions from this. From this paper now, we will be doing questions 4, 6, 8, and 10. Right? These are the questions that most of you have asked about. 4, 6, 8, and 10. So starting from 4, the even numbered questions. 4, 6, 8, 10. Okay, so November 2022, paper 1, variant 3. We're doing 4 questions from this, which are relatively more difficult. Okay, let's start with this one. A large industrial water tank is such that when the depth of the water in the tank is X meters, the volume of water in the tank is given by this formula. Water is being pumped into the tank at a constant rate of 3.6 meter cube per hour. Rate of change of water is measured in volume. So we can say we are given dV over dt, right? Rate of change of volume, dV over dt, that is equal to 3.6. Find the rate of increase of the depth of the water when the depth is 4 meter, giving an answer in centimeter per minute. Okay, now we have to be careful here. This is meter cube, and they're saying centimeter per minute. So there's a mismatch of units as well. We have to be careful about that. Let's do everything in the unit that's given. First of all, that's in everything is in meters, right? This is V meter cube. This is X meters. The depth is represented by X. Volume is represented by V, and we have time. Time is being measured in hours. Time is being measured in hours. Okay, so dV over dt is given. And what we have to find out is dx over dt. That's what we're looking for. Let's make a chain for this. What's dx over dt going to be equal to? It's going to be a product of two fractions. The numerator of the first fraction is going to be dx. The denominator of the second fraction is going to be dt. And in these places, we've got the third variable, which in this case is dv. So we've got dv and dv here. Now, dv over dt is something that we know. That's 3.6 they gave us in the question statement. The problem is we don't have dx over dv. For that, we need some equation that connects x and v. Do we have that here? We are given this volume function. Let's use that. V equals 243 minus 1 over 3 into 9 minus x whole cube. That's the volume function. Okay. And what we want to do is, we want to differentiate it. dv over dx. What does that give us? Derivative of 243 is just 0. Derivative of this expression, what would that be? Minus 1 over 3 remains as it is. We multiply by the power, subtract 1 from the power, which becomes 2. Multiplied by the derivative of what is inside. Derivative of minus x is minus 1. Simplify this. Let's see what that gives you. 3 and 3 get cancelled. Minus and minus get cancelled. And we have 9 minus x whole squared. That is dv over dx. Okay. Now we want the value of dx over dt when the value for x is equal to 4. So what we can do is we can input x equal to 4 in this now. Put x equals 4 and see what that gives you. 9 minus 4 whole squared. That's 5 squared. So dv over dx at that particular point turns out to be 25. We want dx over dv here, so that will be reciprocal of this. So that's 1 over 25 times 3.6. You can see what that turns out to be. What do we get from this? What's this value? 0.144. Can we, is that exact? Okay, so I'm assuming that's exact then. 0.144. Now, you have to be careful. This is in meters per hour because the unit used for length is meter here, and for time it's hours. So we have to convert it to centimeter per minute. Okay, centimeter per minute. We have to do that conversion. How do we do that? You can think of it like this. This is meter per hour. How do you convert meter to centimeters? You can multiply that by 100. How do you convert hours to minutes? You multiply that by 60. So that will convert it to centimeter per minute. You can see what that value is. What do we get from this? 0.24. 0.24 centimeter per minute. That is what we wanted to find out here. This is our final answer in centimeters per minute. Okay, so we had to be careful about that unit. It doesn't happen a lot in paper one, but sometimes it can, like in this question. There was a mismatch of units, so we had to be careful about that. They wanted the answer in centimeter per minute, and the information given was in meters and hours. Oh, so that's the first part. Let's go one now to the next one. It says, okay, now that's the only part of this question. Okay, that was 4. No problem in this one. Okay. Okay, some of you have actually asked about that as well. So what I do is I'll do this quickly as well. The function transformation question, this one. The diagram shows a curve which has a maximum point at 812 and a minimum point at 80. The curve is the result of applying a combination of two transformations to a circle. The first transformation applied is a translation of 7 minus 3. The second transformation applied is a stretch in the y direction. State the scale factor of the stretch. Okay, now, how do we think about this? Stretch is in the y direction. So that means there's only vertical stretch. There is no horizontal stretch, right? If there is no horizontal stretch, we can say the radius of the circle is going to be this. What's this? A length. This is 2 units. So the radius is 2 units. So originally it was a circle. So the original circle would have looked something like this. As in terms of size, it would look something like this. It would have a radius of 2. So vertically, now what was supposed to be 2 earlier is 6 units, right? From 6 to 12, that is 6 units. It was supposed to be 2 initially. So it's getting multiplied by 3. So what's the scale factor of that stretch? That would be 3. Okay. State the radius of the original circle. Well, we figured that out already. The radius was supposed to be 2 because that's what we see here. If this was the center on horizontal, there's no stretch in the horizontal direction, so that will just be 2. Yes.
Could you explain the scale factor stretch again? I didn't understand.
The question says it's a stretch in the y direction. So it's a vertical stretch. That's what we know for sure. There's no horizontal stretch. They have not mentioned anything like that. So the stretch is only in the vertical direction. Stretch is only in the vertical direction. Horizontally, it's the same size as it originally was for the circle. Now, horizontally, you can see this is the complete distance, 4 units. So center would be somewhere in the middle. What will be the radius? The radius would be 2. Now, the radius is going to be 2 on all sides, like this. So the original circle would be of this size. It would look something like this. Now, what stretch is this in the vertical direction now? You can think of the radius or the diameter. Radius or the diameter of the circle. What's the diameter of the circle? Vertical direction. This is 4 units. Originally, it was supposed to be 4 units. After the stretch, it becomes 12 units. Or you can think about the radius. Originally, it was 2 units. After the stretch, it becomes 6 units. So it's getting multiplied. It's getting multiplied by 3. So that's the scale factor. Make sense?
Yes, thank you.
Okay, no problem. Okay, so we figured out the radius as well. Now it says state the coordinates of the center of the circle after the translation has been completed, but before the stretch is applied. After the translation has been completed, but before the stretch is applied. Okay, so what was happening first? What was happening first was translation, okay, and then it is a stretch. Now, in this final diagram that we are getting, the center of this figure is somewhere around here. This is the center at this point, okay, of this diagram after the stretch. Now, what about before the stretch? The stretch had a scale factor of 3. Stretch had a scale factor of 3. If we want to reverse that stretch, we want to get back to the original figure. When we do a stretch, we multiply by the scale factor. Now we have to do the opposite of that. We have to go back to the original figure. So we divide by 3 now. Whatever is the y coordinate is 6. Divide the y coordinate 6 by 3. What does that give you? That takes this point to 2. This is what the center would be after the translation, but before the stretch. So we have just reversed the stretch, right? When you stretch this point, its y coordinate would get multiplied and go there. So if you had to go back, we do 6 divided by 3, and that gives us that point. What's that point? That's 8 and 2. So the center would be in this position, 8 and 2. These are the coordinates of the center in this case. All right. So if you have to reverse a stretch, whatever is the scale factor, you just take the reciprocal of that and you go back to the original diagram from that. Now it says state the coordinates of the center of the original circle in the very beginning. What's the scale? What's the center going to be for the original circle? So now what we have to do is we have to reverse this translation as well. How do you reverse this translation? The translation in this case is 7 minus 3. If you reverse that, in this case, you're going 7 units right. If you want to reverse that, you would go 7 units left. So that will become minus 7. This translation is 3 units down. Minus 3 is 3 units down. If you want to reverse this, you would go 3 units up. So that will be plus 3. This would be the translation that you would have to do to go back to the original point. Minus 7 and 3. Okay, so you go 7 units to the left from this point, and that takes you here. And then 3 units up, 2, 3, 3, 4, 5, and that will give you this point here. You can see the coordinates of this point. This is 1 and 5. This is what you write there. The coordinates of the original circle, the coordinates of the center of the original circle, they would be 1 and 5. Make sense? This was a bit tricky, to be honest, because we had to do the opposite of, we had to do the reverse transformations. So it required some thinking. Any issues with this? Wouldn't it be plus 7? 7? Okay. When it's a translation vector, this means 7 units right, and this means 3 units down. If you were to represent this transformation in terms of a function, in the function you would have something like this: x minus 7 inside and minus 3 outside. For the vertical translation, it's the same sign. For the horizontal translation, in the function notation, it's the opposite. So in the function notation, minus 7 means right, and plus 7 means left. In the vector notation, here, 7 still means it's to the right. Is that okay? Yeah, all right. Let's move on. So this is the next question that you're asking about now. It's given that alpha equals cos inverse of this. And what we have to do is, we have to find, without using the trigonometric functions on your calculator, the exact value of 1 over sine alpha plus 1 over tan alpha. Okay, now how do we think about this? Cos inverse of 8 over 17, that is equal to alpha. If I take this to the other side, that will give me cos of alpha equal to 8 over 17. All right, this is what cos of alpha turns out to be. Now, once you have cos of alpha, what you can do is you can find the value for sine alpha from this and also the value for tan alpha from this. You can find both of them, right? Now, you can do this using identities. You can do this using the right angle triangle. Both of them are fine. Both of them will work. So you can do it any way you like. If you want to use identities here, it would work like this. You can say, let's find sine alpha. How do you do that? You would say sine square of alpha plus cos square of alpha is equal to 8 over 17. You know the value for cos alpha, so it becomes sine square alpha plus 8 over 17 whole squared. No, there's something wrong here. Sine square alpha plus cos square alpha is 1. So this equals 1. And now we can say sine square alpha equals 1 minus this. You can use your calculator for normal calculations. You're just not supposed to do this on your calculator, that you say cos inverse of 8 over 17. You cannot do this on your calculator. That's what is not allowed. Okay, otherwise, simple arithmetic calculation, you can still do that. You can say this is 1 minus 64 divided by 17 squared. And that gives us 225 over 289. Take square root of that, and that will give you the value for sine alpha. That's 15 over 17. That's sine alpha. And then you can find tan alpha as well. What would that be? Tan alpha would be sine alpha over cos alpha. So that becomes 15 over 17 divided by 8 over 17, which is 15 over 8. So we've got the value for sine alpha and tan alpha. All we have to do now is input those values inside this expression and we get the result. That's extremely straightforward. 1 over tan alpha one over sine alpha, first 1 over sine alpha plus 1 over tan alpha, that is equal to, just do reciprocals of this, 15 over 17. What will that become here? 17 over 15 plus tan alpha. 1 over tan alpha becomes 8 over 15. And that is going to be 25 over 15 or 5 over 3. And that's the value that we were looking for. That's your final answer. These are easy 5 points, to be honest. Nothing complicated here. This is one way of doing this. You can also do this using the right angle triangle. You can think of it like this, that if it's 8 over 17, cos alpha is 8 over 17. Think of this as base over hypotenuse. So can you find the perpendicular from that? What's the perpendicular going to be? Hypotenuse squared minus the base squared, square root of that, and that will give you something. This is going to turn out to be 17. This will turn out to be 15 for you. That's the perpendicular. And then you can write down the value for sine alpha from that and the value of cos alpha. Sine alpha is perpendicular over hypotenuse, so that's 15 over 17. And cos alpha would be base over hypotenuse, that's 8 over, cos alpha is already given. You have to find tan alpha. Tan alpha would be perpendicular over the base. Perpendicular is 15, base is 8, 15 over 8. And that's it. We got the same values here. And then you can just input them in that expression. You get that expression, get that answer from here as well. This could be another way of doing this. That would also work. So at the end, you just do the same thing here. And you get the same result at the end. Make sense? That was question number 6. Any issues with this? So yes, both of these methods work. All right. Okay, good. Let's move on to the next one now. Let's move on to the next one. This was question number 6. Yes, so both of these methods work. We've discussed both of them, right? Both of these methods work. You just have to be careful about this plus minus signs. In this case, it doesn't matter because all of them turn out to be positive, but sometimes they specify that the angle is obtuse or the angle is in a particular quadrant. In that case, you have to consider the positive, negative signs according to that quadrant. For example, if it was the second quadrant, you would, if it was the fourth quadrant, for instance, in the fourth quadrant, you would input sine as negative and also tan as negative. Both of those values, you would write them as negative in that case if it was the fourth quadrant, right? So that's one thing that you have to be careful about. In this case, it doesn't matter because they've not specified that the angle is in a particular quadrant. This is the next question that you're asking about now. Question number 8. Let's try this. It says, the diagram shows two identical circles intersecting at points A and B and with centers at P and Q. The radius of each circle is r and the distance PQ is 5 over 3 times r. PQ distance, okay, so that distance is this. Find the perimeter of the shaded region in terms of r. So we are essentially looking for this arc length. Once we have one arc length, we just multiply that by 2 to get this complete perimeter, right? So that's what we have to do. Now, how do we figure out this arc length? That's the question. So what are we given? We're given this radius of one circle. They're both identical. Radius of the other circle is also going to be the same. So we could say this is also r. So we have an isosceles triangle here. And this base, this complete length they have given is 5 over 3 times r. All right. Now, if that's 5 over 3 times r, what we can say is, if we break it into two parts, this is the base of the isosceles triangle, right? If you break the base in the middle with a line like this, you get two right angle triangles from that, right? Such that this point M is going to be the midpoint of P and Q. So we've got two right angle triangles. Now, if you look at the right side, for instance, in this triangle, AMQ, in this triangle, we know the hypotenuse, that's R. We know the base of the triangle now because the complete length PQ is 5 over 3 times R. What will be half of that? It'll be, this isosceles triangle is going to be divided into two parts. So what will be the right side here? This side here, that will be 5 over 6 times R. Okay, so the right angle triangle on the right side, we know the base of that triangle now. We know the hypotenuse. Let's say this angle is theta. Can we find the value of theta somehow? We can use trigonometry. It's a right angle triangle. We know the base. We know the hypotenuse. Base and hypotenuse are connected by cos. So cos of theta equals base, which is 5 over 6 times r, divided by the hypotenuse, that's r. R and r get cancelled. And we can find the value of theta from this. You can see what that is. Cos inverse of 5 over 6. What do we get from this? Make sure that you're using radians. Do not use degrees. What do we get from this? Yes? Anyone? 0.5658. Thank you. Theta turns out to be 0.5658. Now, that's the angle that we have here. Now, what we can do is we can find the complete angle. That's one idea. Find this complete angle, multiply this by 2, and then find this arc length. Or you can just find this arc length and then multiply that by 2 to get the complete arc length. Either way, you get that complete arc length. What I'll do is I'll multiply this by 2 to get that complete angle first of all. Let's see what that turns out to be. The angle AQB, that will be 2 times this, 0.5628. What's that? That's 1.1 something. 5856. Okay, thank you. 5856. So I think this is 5856. Okay, all right. Then you multiply this by 2. What do you get from that? 1.1712. 1.1712. Okay, all right. Thank you. 1.1712 or 13, depending on what value you're using, but that's okay. This is 5 significant figures, so that should be safe. We've got this complete angle. Now we can find half of that. In fact, one arc length here, arc AB, and just multiply that by 2. Arc AB, that's R into theta. Radius is R. Angle is theta. That's 1.1712. And then what's the perimeter? You just multiply this by 2 again. 2 times this, 2 times 1.1712 times R, and that will give you the complete perimeter, because in the perimeter you've got 2 arc lengths, one this and the other this. And that will be the final result. That's 2.34 times R to 3 significant figures. That's what we were looking for in the first part. Okay, that's the perimeter in terms of R. Now it says, find the area of the shaded region in terms of R. Area of the shaded region. How do you find the area of the shaded region now? Again, in terms of R, we can break it into 2 parts again. We can say let's find the area of half of this. Find the area of one segment. So find the area of this segment. Multiply that by 2. Right? Find the area of one segment and just multiply that by 2. Okay? Let's do that. Segment AB. Let's see how we can find that. You can use the direct segment formula if you want. If you remember that, that's half R squared times inside bracket theta minus sine theta, or you can just evaluate sector and triangle separately, subtract them. That's also fine. So segment AB, what's that? That's equal to the area of the sector OAB minus the area of triangle OAB. Area of sector is given by half R squared theta, half into R, that's just R squared into theta. Angle, that complete angle, we found that to be 1.1712 here. That was the complete angle, 1.1712. 1.1712. Subtract from that area of the triangle. Now, in this triangle, we know that this length is R, this length is also R. We know the angle between them, the included angle. So the area of the triangle is going to be half into R into sine of the angle between them. So half into R into sine of 1.1712. The question does not mention that you want an exact answer. Just put this whole thing on a calculator. Take R square common, put everything else in your calculator like this. You'll say this is 1/2. Make sure your calculator is in gradient mode. 1/2 into 1.712. 1.1712. You have to be careful with this, unlike me. 1.1712 minus 1/2 times sine of 1.1712, close the brackets. And that gives you something that's 0.12499. You can say that's 0.125 to 3 significant figures times R squared. That's the area of that segment that we were looking for. Make sense? Is that all right? Okay, good. Let's move on now to the next part. In fact, that's it. So question 8 is done. And now question number 10. That's the last question that we're doing from this paper, and that's it for this session. Question number 10. We've got equation of a circle that is x squared plus y squared equals 2 and a straight line that's y equals 2x minus 1. They intersect at points A and B. We can see those points here, point A and point B. The point D on the x-axis is such that AD is perpendicular to the x-axis. AD, this is perpendicular to the x-axis. Find the coordinates of the point A first of all. Okay, now how do we do that? It's 4 marks. We can just solve them simultaneously. A is the point of intersection of the line and the circle. So just solve those two equations simultaneously and see what that gives you. X squared plus y squared equals 2. That's the equation of the circle. Equation of the line is y equals 2x minus 1. Input that equation in the circle's equation, and that will give you x squared plus 2x minus 1 whole squared equals 2. Let's simplify this. X squared plus a minus b whole squared. The answer is 0.250 for the previous question. Oh, okay. I'm sorry about that. We just found the area of one segment. Okay, we just found the area of one segment. We had to multiply that by 2. Yes, okay. I just looked at your messages. Okay, so we had to multiply that by 2. So we'll lose 1 mark there if we don't do that. We just found the area of one segment. We had to find the complete area, right? So the shaded area would have to be 2 times that. So this would be 2 into 0.125 r squared, and that would be 0.250 r squared. Yes, that's the shaded area that we've got. Okay, thank you for that. All right, let's move on. Let's move on to question number 10. So we've got these two equations, these two functions. One is a circle, the other is a straight line, right? Now, we have to find the point A. That's the point of intersection of the circle and the line. How do you find points of intersection? We solve those two functions simultaneously. In this case, we can use substitution. Input y equals 2x minus 1 inside the equation of the circle, and then just solve that further. This is a minus b whole squared. That will become 4x squared minus 2 into 2x into 1. That's minus 4x plus 1. That equals 2. Take all terms to one side. 5x squared minus 4x minus 1 equal to 0. Can we factorize this? 5 and 5 and 1. Yeah, that should work. We can use 5x squared minus 5x plus x minus 1 equal to 0. We get two factors from that, 5x plus 1 and x minus 1. X either equals minus 1 over 5 or x equals 1. We are looking for the coordinates of the point A. Its x coordinate is supposed to be positive, so we only consider this point. X equals 1, put that in the other equation. Y equals 2 into 1 minus 1. The value for y turns out to be 1. So the coordinates of A therefore are 1 and 1. And that's what we were looking for here in the first part. Okay, so we've got the coordinates of the point A now. Now it says, find the volume of revolution. Oh, wow, that's interesting. A volume of revolution in an equation of circle question. When the shaded region is rotated through 360 degrees about the x-axis. Give your answer in this form where A, B, C, and D are integers. Now, what's the formula for volume of revolution about the x-axis? The formula looks like this. Volume of revolution about x-axis, that's pi into integration of y squared with respect to x. Limits are values of x. Shaded region is supposed to be rotated about x-axis. Okay, shaded region, this region, this is rotated about the x-axis. And we have to find the volume of revolution from this. Now, how do we do that? We need limits for that, for the shaded region. Do we have those limits? We know the coordinates of the point A. So that means the x coordinate here is supposed to be 1. This point is 1. What about this point here? We'll have to find that. That's the x-intercept of the circle. And it doesn't really require us to find anything though, because this is just equal to the radius of the circle, right? Because the center is at the origin. This is x squared plus y squared. That's x minus 0 whole squared plus y minus 0 whole squared. So the center is at the origin. So whatever is the radius of the circle, that will be this point here, right? The distance from origin. 2 is what we have on the right side. Square root of that is the radius. So this point is supposed to be square root of 2. So we have the limits from 1 to square root of 2. Okay, limits are from 1 to square root of 2. And now we just have to apply the formula and find this volume. What's the equation of circle that we're given? X squared plus y squared equals 2. Make y squared the subject here because that's what we need for that volume formula. Just input values in that now. Vx, that is equal to pi into integration of y squared with respect to x. Limits are from 1 to square root of 2. Now we want an exact answer at the end. Okay, now don't worry about this weird form that they've given us. You will automatically get this when you integrate, input the limits, you will automatically get a form that looks something like this. Okay. So let's just first integrate this. What's the integration of y squared? Integration of y squared is just going to be y cubed over 3. Limits are from 1 to square root of 2. Let's input those limits. 1 to square root of 2. Input square root of 2 once. So that gives you pi into square root of 2 whole cube divided by 3. Subtract from that 1 cube over 3. And see what you get from that. Pi outside as it is. Under root 2 whole cube. You can put that on your calculator. Your calculator will give you 2 under root 2 from this. Okay, you can just put that on a calculator like this. Under root 2 raised to power 3. And that's 2 under root 2. That's basically 2 raised to power 3 over 2. That becomes 2 under root 2 divided by 3 minus 1 over 3. And now let's look at that form that they want. They want pi over some number common outside. So we can take 3 common from the denominator. So we have pi over 3. And then inside we're left with 2 under root 2. 2 under root 2 minus 1. Is that okay? Although, there seems to be some problem. Okay, I'm sorry. What am I doing? What have I done here? So we had to integrate y squared, and I am too distracted. Y squared is 2 minus x squared. We had to input that. I just integrated y squared there. This was this. Limits are from 1 to square root of 2. And now we can just integrate this. So I just integrated that directly. That cannot even be done because this is with respect to x and this was y squared. We had to input that first. Integration of 2 is 2x. Integration of x squared is x cubed over 3. And the limits are from 1 to square root of 2. Okay, sorry about that. Let's input the limits now. Pi remains outside as it is. What does that give us? 2 under root 2 minus under root 2 whole cube divided by 3. And then we input 1 as the limit. And that gives us 2 into 1 minus 1 cube over 3. Subtract that from this. See what this gives you now. Pi remains outside as it is, and you have 2 under root 2 minus this. When you put this on your calculator, is going to give you 2 under root 2 divided by 3 minus 2 plus 1 over 3, and that will give you the result. You can simplify this. Let's see what we get from this. 3 under root, you put this on your calculator and you should get 1 minus 1 over 3. That's 2 into 2 under root 2. That will be 4 under root 2 divided by 3 minus 2 plus 1 over 3. What's that? Minus 2 plus 4, minus 2 plus 1 over 3. What's that? Make sure you have good sleep before you go to the exam, so you're not making any errors like I'm doing right now. This is minus 5 over 3. Okay. And now we can take 3 common outside. That leaves us with pi over 3 into 4 square root of 2 minus 5. And now these all numbers are different. That makes sense. You can just confirm this as well from your calculator. Put this whole thing in a calculator. You'll get a decimal value. So this integral in a calculator, just compare that with this, that it's matching as we have done in previous papers as well before. Okay, so that's the final answer that we get. Any issues with this? Any questions, anyone? I will be posting some, I will not be making a practice mock as such, but I'm planning to work on some videos overnight, which will, compile the most difficult questions, from the last 4 or 5 years of papers from each topic. So I plan to work on that overnight. For some topics, not for all of them, like functions, function transformations, quadratics, trigonometry, equation of circle, and possibly differentiation, integration if I get time for that. That should be helpful. But no, I don't plan of doing a mock as such. Tomorrow, we will be discussing any random questions that you might have from any papers, from anywhere, any general advice that you want before the exam, any specific advice or general advice that you want before the exam. We will have a session in the evening. So tomorrow we're not going to have our M1 or S1 class. It will just be paper 1. So we will start around maybe 6:30 or 7 p.m. and we'll go on as long as we need to. Okay, I'll have a look at that. Actually, let's complete this question and then we'll have a look at that. Find an exact expression for the perimeter of the shaded region. Exact expression for the perimeter of the shaded region. Okay. This is the shaded region. We want the perimeter for this. We know the height, that is 1. We know the base, that's under root 2 minus 1. Right? So we know the base as well. The only question is, what's that arc length on the side? That's what you want to find out. Now, how do you find that arc length? For that arc length, you have the radius already. Radius is square root of 2. You need the angle. You need this angle somehow. How do you get this angle? You know the base is 1. You know that this is 1. So it's an isosceles triangle. Isosceles right angle triangle. This is 90 degrees. The others are going to be 45 degrees. Or in radians, they're going to be pi over 4. So this angle is supposed to be pi over 4 for that reason. So the angle for that arc, that is pi over 4. So we can just use the arc length formula. And that will give us that arc length. Add the other 2 lengths with that, this length here and this length, and that will be the perimeter. Let's do that. Let's call this point something. I'm going to call this point E. Arc AE. Let's figure this out. I'll do this working here and then copy that below. Arc AE. AE is arc length is r theta. Radius is under root 2 into the angle, that is pi over 4. So arc would be under root 2 into pi over 4. That's the arc length. And the other two lengths, one of them is 1 and the other is under root 2 minus 1. Okay, so I can just write them here. AD is 1, DE is under root 2 minus 1. Just add them up all together and that will give the perimeter. And that's it. That's the final answer. This is what we get from this. All right, that's the pyramid. Okay, there's a design going on here. I'll take a 1-minute break and then we resume after that with any questions that you have. Okay, so this is a confusion that a lot of people have. That when do you put plus minus with the square roots and when do you not put plus minus with square roots? I think we discussed this in one of our classes earlier as well, but I'll repeat that. If you have something like this, x squared equals 3, for instance, and you want to find the values of x from that, what you do is you take square root on both sides. When you take square root on both sides, you say it could be plus minus square root of 3. You put plus minus on the right side, and you get two solutions from this. Either x equals under root 3 or x equals minus under root 3. Compare that with when you have something like this, y equals under root 5 plus 1. Now, in this case, you do not say, or let's actually use another integer that's a perfect square, under root 9, for instance, or a different one because that will confuse you with just that 3 in the previous example. Let's say under root 16. Now, in this case, you do not say that it is plus minus 4 plus 1. No. This is under root 16. The square root is already there. If the square root is already there and they don't have anything outside, that means it's positive. It's this case. If there was a negative, they would have that explicitly outside like this. If there's nothing outside, that means it's positive. It's the positive square root. So when you take square root of this, you just leave it as plus 4 plus 1, and that will be just 5. When you take square root yourself, you put plus minus. When the square root is already there, it would have either a plus with it or a minus with it. It'll have either a plus with it or a minus with it. You just consider that same sign that is there. You don't put plus minus in that case. So when you take square root yourself, you put plus minus. When the square root is already there, you just use the sign that is already there with that square root. If there's no sign, that means it's positive. If there's a minus outside, that means it's negative. So you just leave it as it is. Whatever sign is there already, you just use that sign. Is that okay? Was that the question? That's what I understood from that discussion in the group. Or what, is there any other confusion apart from this as well? A photo of what? Of their calculator, where they evaluated square root of 1 and then they had minus 1/2 here. Okay, so what about this? What's the question on this? If there's a plus minus with this, why would there be a plus minus with this? This is minus 1/2. This is not even a square root. This is a half root. So if you have, for example, something like this, a raised to the power 1/x, that can be written as, or 1/n, let's say, a raised to the power 1/n. That's the nth root of a. So whatever is here, when it comes to the power, it becomes reciprocal of that. So it will become 1 raised to the power minus 2. Now what's that? 1 raised to the power minus 2? That's 1/1 squared. That's just 1. It's not even a square root. It's actually a square. Why would we have plus minus with this? If there is a minus 2 and minus 4, okay, so if you have a minus 2 there, then we take that to the power and it becomes 1 raised to the power minus 1/2, and that becomes 1/1 raised to the power 1/2. That's just 1/1, and that's 1. That remains 1. Why? Because that root is already there. If we had to consider a negative root as well, we would have had a minus sign outside there already. If there's no sign outside, that means it's positive. You only put plus minus when you take square root or any root yourself. For even roots, for example, square root, fourth root, sixth root, eighth root, when you take that root yourself, you put plus minus. When it's already there, this notation, for example, it means that it's plus square root of 2. If it was minus square root of 2, they would have written minus square root of 2 like this. Okay. So if they already have this, that means there's a plus with that. And this is a minus with that. So that's the takeaway. When you take a root yourself, then you have to consider plus minus for even roots. If they already have that there, then you do not consider plus minus. Okay, all right. So that's it. I hope that was helpful. Now tomorrow we'll have a session around 6:37. I will confirm the exact time, and we will continue with that for as long as needed. Your paper is in the PM on the day after tomorrow anyway, so we can extend it for however long it's needed. So in that session, I will just be answering any general questions that you might have from any topic, or any specific questions that you have that you found difficult from any paper in the past papers. We could discuss those questions. Any specific concept that you're finding very difficult, we could quickly go over that as well. So that's what we are going to do tomorrow, inshallah. The next M1 class is actually today, but okay, so we'll talk about that later. We also have the workshops coming over the weekends, over the next weekends now. This Saturday, M1, and then the Saturday after that, on 14th, inshallah, we'll have S1. And then for P3, we will have Friday and Saturday, the week after that, inshallah. Okay, and the past paper sessions, we will continue with them as planned as well, inshallah. That's it for today. I'll see you again in the next session. Okay, part B. Okay, so part B was, we just used the volume formula, pi into integration of y squared with respect to x. And then since this was the equation of the circle, we made y squared the subject from that. Y squared equals 2 minus x squared. We put that in the formula here. Earlier, I, for some reason, I just, forgot to input that here. And I just integrated directly, which could not be done, of course. So that's why I changed my working, if that's what you're asking. So we replace y squared with 2 minus x squared here, and then we integrate that. Okay. Integrate that, input limits, simplify that, you get a result. Is that okay? All right, so I'll see you again in the next session then. All the best for your exam. Allah Hafiz. I'll see you tomorrow, inshallah, with the next P1 session. Allah Hafiz.